with trigonometry. Now let us first consider what is trigonometry. Trigonometry basically consists of two words. The first word is trigon, or sometimes called as trigonon, plus metron. Now this word trigon or trigonon refers to a triangle. This means a triangle, and metron means to measure. So therefore here we are talking about measuring a triangle in different ways, and this is a very old branch of mathematics. So when it started with right angle triangles. So firstly we will be considering some right angle triangles, and then we will be seeing how we can move forward from there. So let us just consider a right angle triangle first, and we will consider a very famous theorem which is related to right angle triangles. Let us say that we have a right angle triangle ABC here. Angle B is a right angle in this triangle ABC. Now, as many of you will be knowing that the side which is opposite to the right angle is given a special name. It is known as the hypotenuse of the right angle triangle. Okay. So in short we can call this as H. Now apart from this, if we consider this triangle, there are two angles, and some of you may be knowing how to denote an angle. So here if I talk about this angle, I can call this as angle A. That is one way of representing this. Another way of representing this is I can also call this angle as angle BAC. This is known as 3-point notation, and the previous one is known as 1-point notation for an angle. So I can consider angle A, I can consider this angle here as angle A, I can call this as angle A, or I can call this as angle BAC. Same way the angle here, it can be denoted as angle C or angle ACB. Okay, so in a right angle triangle basically there are two more angles. Here in this triangle I can say that I have angle A and angle C. So if I consider any one of these two angles, let us say if I am considering angle A. So in a particular question, if I am considering angle A here, then angle A will be known as the angle of reference, because in a right angle triangle, apart from the angle B which is 90 degrees, there will be two more angles, angle A and angle C. And if I consider any one of them in a particular question, if I am considering angle A, if I am solving it with respect to angle A, if I am talking about angle A, then angle A is known as the angle of reference, and we have to remember this. In a particular question, if I am talking about angle A, then it is angle of reference. Okay, so now let us just go back to this triangle once again. We will again consider the same triangle ABC. Now if I am considering angle A here, then angle A becomes the angle of reference. I am calling this as the angle of reference. Now as I told you, the side opposite to the right angle is called as hypotenuse, so we are denoting that by H here. We are denoting that by H here. Now if angle A is the angle of reference, then the side opposite to the angle of reference is known as perpendicular here. Now some of you may not agree with this with your present knowledge. You may be thinking that perpendicular is a side. If I draw a triangle like this, then this side is known as perpendicular here. But that is not true. In trigonometry, any side which is opposite to the angle of reference will be known as perpendicular. In short, we will write that as P, and in some other textbooks you may also get this side written as the opposite. In short, it will be written as O. So we can call this side as perpendicular or the opposite. So side BC here, we can say side BC here is the perpendicular or the opposite for triangle ABC if we consider angle A, if angle A is the angle of reference, and the side which makes up the angle of reference along with the hypotenuse. As we can see here, angle A is made by two sides. Which are the two sides which are making up angle A? The two sides are side AC and side AB. Now as we know that AC is already the hypotenuse, so the remaining side is side AB. So the side which makes up the angle, this side will be known as the base. In short, we will write that as B. Another name for base is adjacent. In some of the textbooks they use the concept of adjacent. In short, we can write that as A. In some of the textbooks you will find that as written as adjacent and opposite, and in some of the other textbooks you will find that written as base and perpendicular. Now here I will be using the concept of base and perpendicular. So as I told you some of the things regarding the right angle triangle, let us just discuss once again. In any right angle triangle there is a right angle, and apart from that there are two more angles. Here if I consider angle A, then the side opposite to angle A, which is BC here, so BC will be known as perpendicular and AB will be known as the base, and the third side, as I told you earlier, will be denoted by H, which is the hypotenuse. So in any right angle triangle, for us in trigonometry there are always three sides: perpendicular, base and hypotenuse. Now let me just clarify one more thing. As I told you that angle of reference is important, so when I was considering A as the angle of reference, then BC was the perpendicular and AB was the base here. But if I change the angle of reference, if in a particular question we are not considering angle A but now we are considering angle C, so the side opposite to angle C, if you see here, it's a good thing you see the C or you don't see the C. Okay, as you see the C and as you consider the C, I'm talking about this C, so you see this C, and then the side opposite to this, you can see that also the side opposite to this is AB, and AB will now not be considered as base but that will be considered as perpendicular. It is perpendicular for angle C and it is base for angle A. Same way here for the angle C, the side which is making up the angle C is made up basically by two sides. One of the sides which is making up the angle C is this side, side AC, and the other side is side BC. As we know, AC is the hypotenuse, so apart from hypotenuse, the second side which is left here, that side will be considered now as base for angle C. So for the angle C, the side BC will be considered as base. So in trigonometry, for any particular triangle, the concept of perpendicular and base is not fixed. Perpendicular and base, their positions can be interchanged depending on the angle. Let me just clarify this once again. I'll make two triangles here. This I'm just trying to take more time explaining this because this is a very important concept. If you don't understand this, you may not understand a lot of problems. So I'm drawing two triangles side by side and then I'll try explaining again what I did earlier. So there are two triangles here. There's some problem here. There are two triangles here. Both are triangle ABC. In both the triangles, angle B is the right angle. And then in the first triangle, in the first figure, I am taking angle A as the angle of reference, and in the second figure I am taking angle C as the angle of reference. If I take angle A as the angle of reference, then the side opposite to angle A is BC, so BC here will be called as the perpendicular, and the side which is making up angle A, that is the side AB, apart from the hypotenuse, this side here will be known as the base. Same way in the second figure, if I take here angle C as the angle of reference, then the side which is opposite to angle C, the side AB, this side will be the perpendicular, and the side BC, which is making up angle C, apart from the hypotenuse AC, this side BC here will be known as the base. So in the same triangle, triangle ABC, hypotenuse will always remain fixed, but perpendicular and base can change according to the angle of reference. If we are talking about angle A, BC is the perpendicular and AB is the base. If we are talking about angle C as the angle of reference, then the side AB will be the perpendicular and BC will be the base. So after clearing the concept of base and perpendicular, let us just clarify one more concept. Let us say that if I have a right angle triangle, again I am trying to draw a right angle triangle here. This is triangle ABC, same type of triangle which I had drawn earlier, and I draw here one more triangle, triangle PQR. Now some of you at least may be familiar with the concept of similarity. Now in these two triangles, both are right angle triangles, if one more angle becomes equal, suppose here I say angle A is equal to angle P, then both these triangles will become similar and the ratio of their sides will be equal. I can also say like this, that the sides will be proportional. I can write like this. I can say that for these two triangles, if I write the ratio of AB upon AC, AB upon AC will be equal to PQ upon PR, and that will also be equal to the ratio of third sides. I have written here AB upon AC and PQ upon PR. If I write any other ratio of corresponding sides, it will also be equal to that. For example, if I write from the first triangle, if I consider the ratio of AB and BC, okay, if I consider the ratio of the two sides here, AB upon BC, that will be equal to PQ upon QR. That will also be equal. Basically here what I'm trying to convey here is this, that if two triangles are similar, then the ratio of their corresponding sides are same. Just like I have written two of the ratios here, if I want to write in general, then I can write the corresponding sides. I could have written like this also. All the three I could have written in all the three sides I could have considered. The first triangle is having sides AB, BC and CA, and the second triangle is having the sides PQ, QR and RP. So I could have written like this, that AB upon PQ is equal to BC upon QR is equal to CA upon RP. But I did not want to write like this. I wanted to write like this. I wanted to show you this thing, that if two triangles are similar, then if I consider two sides of the first triangle and two sides of the second triangle, then the ratio, both the ratios will have the same value. Let us say that here if the ratio is 1 upon 2, so if the first triangle is having the ratio 1 upon 2, second triangle will also have the ratio 1 upon 2. And in the first triangle, if I consider this particular angle, let us say that this angle here is theta. So if this is theta, then the other one will also be theta, because both the angles are equal. So for a particular angle theta, the ratio of base for this angle theta, as we know, this side will be considered as base and this side will be considered as the hypotenuse. So for a particular triangle, if angle theta is fixed for a particular right angle triangle, if we have a right angle triangle with angle theta, then the ratio of base is to hypotenuse will always be fixed. Same way, if the ratio of bases to hypotenuse is fixed, then the ratio of perpendicular is to hypotenuse will also be fixed. Now this ratio for any particular angle theta, the ratio of perpendicular upon hypotenuse is known as sine theta. Just to give you an example, let us say that if I have a triangle here, this is 90 degrees, this angle here is 30 degree. Now I can write down the ratio of the side BC upon AC. Okay, so if I measure the side BC, if I measure the side AC, and I find out that the ratio here is coming out as half, then I draw another triangle which is probably bigger than this, but which is having the same angle 30 degrees. Apart from the right angle triangle, it is having the same angle. So if I write down again the ratio of QR upon PR, then the value is again going to be half, because as we know, here we wrote the ratio of perpendicular is to hypotenuse, and here also we are writing down the ratio of perpendicular is to hypotenuse. So therefore perpendicular upon hypotenuse, the ratio will always be the same for this angle of 30 degrees. So in place of theta, if I write 30 degrees, then I can write like this: sine 30 degree is equal to half. It will not depend on the triangle, whether the triangle is big, triangle is small, what kind of triangle you have. If one of the angles is 90, the other angle is 30, then the ratio of perpendicular is to hypotenuse will always be half. And that remains true for any angle, whether the angle is 30 degree, 40 degree, 50 degree, 75 degree, any kind of angle you have, the ratio of perpendicular is to hypotenuse will always be fixed. If that angle is found in a right angle triangle, then perpendicular upon hypotenuse will always be fixed. So that fixed ratio is known as sine theta. Sine, the spelling is SINE, which in short we write as SIN. It is not sin, we are not doing any sin here. Mathematicians anyways are not sinful people, so we write sine theta. And the next ratio which we consider here, the next ratio will be cos theta. So cos theta, this ratio is defined as base upon hypotenuse, and the next ratio here is tan theta. Tan theta is written as perpendicular upon base. So these are the three basic trigonometric ratios from which we start with trigonometry. So we should know that for any right angle triangle, the ratio of perpendicular upon hypotenuse is denoted as sine theta, the ratio of base upon hypotenuse is denoted as cos theta, and the ratio of perpendicular upon base is denoted as tan theta. Now this cos is nothing but short for cosine, and tan is nothing but the short of tangent. So these are the three ratios which we have to consider at first: sine theta, cos theta, and tan theta. I will just write down here once again. I'll just write down once again here: sine theta is equal to perpendicular upon hypotenuse, cos theta is equal to base upon hypotenuse, and tan theta is equal to perpendicular upon base. Now how to remember this? How to remember that sine theta is perpendicular upon hypotenuse, cos theta is base upon hypotenuse, tan theta is perpendicular upon base? So we consider the first letter of all these ratios, the three ratios, trigonometric ratios: sine theta, cos theta, tan theta. As I told you, these are known as trigonometric ratios. We consider the first letters of these three trigonometric ratios as CT, and then we consider the letters which are coming here in their formula. So we try forming a sentence which contains all these letters in the correct order. So first is S, so I write here S, I write sum. Now this sum S means sine. Now the next letter is P, so I write here people. So sine is P upon H. So next I will write something which starts with H. So I'll write here some people have. So I got H. So now I know that sine is perpendicular upon hypotenuse. SPH. Sine perpendicular hypotenuse. Now same way we take the other. Some people have. Then the next comes C. So we write curly. So we get the C here. Then we write base. We have to write B. So we write black. Some people have curly black hair. So it becomes cos is base upon hypotenuse, and then next is tan. So we write here turned T. Now T has come denoting the tan, turned permanently brown. So we write here P and B. So this becomes tan theta is equal to perpendicular upon base. As we can see over here, we got P, we got B. So S, P, H. Sine is perpendicular upon hypotenuse. C, B, H. We got cos is base upon hypotenuse. And then we got T, P, B. Tangent tan theta is perpendicular upon base. So we can remember this one sentence: some people have curly black hair turned permanently brown. If we remember this one sentence, then we can remember all the three trigonometric ratios, which are very important from the point of view of trigonometry. Now there may be some other tricks also, which some other teacher may tell you. So if there are some other tricks of learning this, then you can learn them also. If you find this one difficult, I find this one easy. The trick here, the sentence here: some people have curly black hair turned permanently brown. So if I remember this, I remember all the three trigonometric ratios, no problem at all. Now next let us consider the reciprocal of these ratios. As I told you that sine theta is perpendicular upon hypotenuse, but sometimes in the question perpendicular upon hypotenuse is not given, but instead we are given hypotenuse upon perpendicular. Now hypotenuse upon perpendicular I can also write as 1 upon sine theta. If sine theta is perpendicular upon hypotenuse, then hypotenuse upon perpendicular will become 1 upon sine theta. But since it comes very frequently in the question, so this 1 upon sine theta has been given a special name. It is known as cosec theta. So we can write here cosec theta is equal to 1 upon sine theta. Same way the reciprocal of cos theta is written as sec theta. Now let me just tell you one more thing. Cosec is the short form of cosecant, and same way sec is the short form of secant. And then we write here the next one, the reciprocal of tan theta. It is denoted as cot theta. Now these three formulae here, cosec theta is 1 upon sine theta, sec theta is 1 upon cos theta, cot theta is 1 upon tan theta. These three are known as reciprocal relations. Okay, these three are known as reciprocal relations. Cosec theta is 1 upon sine theta, sec theta is 1 upon cos theta, and cot theta is 1 upon tan theta. And since we know cos is base upon hypotenuse, so therefore sec, if we needed to write down sec, then sec will become hypotenuse upon base, and same way cot will become base upon perpendicular. So these are the formulae for sec theta and cot theta. So three trigonometric ratios, and then their three reciprocals and then their three reciprocals. So total we got 6 trigonometric ratios. So there are total of 6 trigonometric ratios which you need to remember now. There may be very easy questions based on these 6 trigonometric ratios using the above formulae. Now let us just consider a few more things. Let us now consider a few more things. Let us consider the ratio of tan theta first. Now as we know, tan theta is perpendicular upon base, and we know this that in a fraction, if we divide both numerator and denominator by the same object, then fraction will not change. So we are dividing both numerator and denominator by the hypotenuse. So if we divide both numerator and denominator by hypotenuse, we get p upon h upon b upon h. But we know p upon h is nothing but sin theta and b upon h is nothing but cos theta. So we get this formula that tan theta is equal to sin theta upon cos theta, and same way we get cot theta is equal to cos theta upon sin theta. Now these two formulae here, these two formulae are known as the quotient relations. So we write here these two are known as quotient relations, important relations. So you need to use them many times in questions, so therefore you have to remember them carefully. These are known as quotient relations. Tan theta is equal to sin theta upon cos theta. The word quotient basically means division. So in these two formulae there is division of sin theta by cos theta in one of them and cos theta by sin theta in second one of them. So therefore these two formulae are known as quotient relations. Now let us consider a few more things here. Let us consider the ratio of sin theta and cos theta. We know sin theta is perpendicular upon hypotenuse and cos theta is, let me just write down once again because it is not looking good. So let us just write down once again. Sin theta, let us just write down here, sin theta is equal to perpendicular upon hypotenuse and cos theta is equal to base upon hypotenuse. Now as we write these two formulae, let us as I told you earlier that there is a very important theorem related to right angle triangles which we will be considering later on. So let us just consider that theorem along with these two ratios here. So if I consider ABC as a right angle triangle, a very important theorem which you studied in previous classes, which is very famous also, known as the Pythagoras theorem. So this Pythagoras theorem here, according to Pythagoras theorem, we can write this as AC square is equal to AB square plus BC square. So AC square can be written as AB square plus BC square. Now in this triangle, if I consider any one of the angles as angle of reference, let us say that if I consider angle C as the angle of reference, then as I know AB will become the perpendicular and BC will become the base. So let us see what happens using this Pythagoras theorem. What happens if we divide here by AC square? So we write here AC square upon AC square, we are dividing by AC square, that will be written as AB square upon AC square, and that will be written as BC square upon AC square. Now as the elementary calculation will tell you, AC square upon AC square is 1. AB square upon AC square can also be written as AB upon AC whole square and BC upon AC whole square. We can write like this. And for this triangle, AB is perpendicular, AC is the hypotenuse, so we can write this as 1 is equal to P upon H whole square plus B upon H whole square. We can write like this. Now as we know, P upon H is nothing but sin theta and B upon H is cos theta. So we can write down here this thing as sin square theta. Sin square theta comes from where? It comes from P upon H whole square plus cos square theta is equal to 1. Now what is sin square theta? Sin square theta is actually, I'll write down here, sin square theta is nothing but sin theta whole square. We don't use this notation sin theta whole square. Instead of that we write sine square theta, and that goes for all the 6 trigonometric ratios. So cos square theta basically means cos theta whole square. So this becomes sine theta whole square plus cos theta whole square is equal to 1, which we can write as sine square theta plus cos square theta is equal to 1. This is the first one of square relations. So I call this the first square relation. So sine square theta plus cos square theta is equal to 1. This is known as the first square relation. From where does it come? It comes from Pythagoras theorem. As I divided by AC square, I get the first square relation, but if I divide by AB square or BC square, then I'll get a different kind of square relation. So since we can divide by 3 sides, so basically there are 3 square relations. So let us see what are those 3 square relations. As I wrote the first one, the first square relation is this one, sine square theta plus cos square theta is equal to 1. The second square relation goes like this, 1 plus tan square theta is equal to sec square theta, and the third one is 1 plus cot square theta is equal to cosec square theta. So 1, 2, 3. These are known as the 3 square relations. In different textbooks you may find different iterations of these. For example, the second square relation in some of the other textbooks, it may be mentioned like this, sec square theta minus tan square theta is equal to 1. Now that is perfectly fine, because if we shift the tan square on the other side, it will become minus. So therefore the relation will become sec square theta minus tan square theta is equal to 1. So in a particular question, if you get sec square theta minus tan square theta, then instead of that you can write 1 here, 1 there, and then same way the third relation can also be written as cosec square theta minus cot square theta is equal to 1. And many times in questions using the first relation, if we use the first relation, sine square theta plus cos square theta is equal to 1, suppose I shift cos square theta on the other side, then I get this thing, sine square theta is equal to 1 minus cos square theta. So 1 minus cos square theta, if you get in a particular question, you can replace that by sine square theta. And same way, if you get 1 minus sine square theta, you can replace that by cos square theta. So these things can be done according to a particular question. So that covers all the basic things regarding the trigonometry. I have tried explaining all the 3 basic type of formulae here. The first one, which I considered reciprocal relations, then I considered the quotient relations, and then I considered the square relations. So all 3 types